In 9.3a, we learned how to find points of discontinuity, and that was by finding the values that make the denominator of a rational function equal 0. We're going to continue with that today and figure out what type of discontinuity it has. All right, so yesterday we only had to worry about the denominator. Well, today kind of changing a little bit. So we know there's discontinuity for each real 0 q of x. So that's the x values that make the denominator equal 0. So we know there's discontinuity, but what type? Well, we're going to look at the zeros of the numerator as well, p of x. If p of x and q of x have no common real zeros, so none of the zeros are the same, then we know for sure that that point in discontinuity is a vertical asymptote. So if no common, it's vertical asymptote. But if they do have a common zero, then that means we have a possibility of having a whole or a vertical asymptote. It's going to be one of the two. So to find the asymptotes and the wholes, our first step is to find the zeros of the denominator, which are our points of discontinuity. Or points of discon, as Whitney says. If the points of discontinuity are found, we're going to see if those are also zeros of the numerator. So we're going to set the numerator equal to 0 and solve. The same thing we did with the denominator. If there's no matching, then we have vertical asymptote. If there is matching, then it's one of these two. We don't know which. All right, so that's our steps. So let's figure out the vertical asymptotes and wholes for the graphs of these functions. All right, for our first example here, remember our first step is to find the zeros of the denominator. So we set the denominator equal to 0 and solve. And we set each factor equal to 0. Get x by itself. So the points of discontinuity are at x equals 2 and x equals 3. Okay. Now, next step is to figure out the zeros of the numerator. So we're going to set the numerator equal to 0. Well, so we get x equals -1. That's not common between the two. -1 was not one of the zeros of the denominator. So that means, what did it mean when it was not common? No matching means they're vertical asymptotes. Okay, so vertical asymptotes are x equals 2 and, that's not and sign x equals 3. So that would be your answer. Ta-da! Okay, let's do the next one. Step 1, set the denominator equal to 0 and solve. We can add 2 to the other side. We get x equals 2. All right, let's see if that matches with what's up top. So on the top, we get x minus 2 times x minus 1 equals 0, so we'll get x minus 2 equals 0. This is looking similar. And x minus 1 equals 0. So x equals 2 and x equals 1. All right, so these two match, and the x equals 1 doesn't match. So since that one was in the numerator, we don't have to worry about that one anymore. So now we're just dealing with x minus 2. What we're going to do from here is we are going to graph and look to see if we can figure out if it's a whole or an asymptote. So graph the original equation. Make sure that you get all your parentheses in the right place. You might want to pause the video here so you can catch up. Now I graphed the equation, and I got what looks like just a straight line. Remember that we're looking for something to happen at x equals 2, which is right here. And right now we don't see anything that happens. There's definitely, I would say there's not an asymptote because our graph, it doesn't like go up and up and up and try to touch the line but never can. It just looks like it goes straight through it. So it's probably a hole. But what we're going to do is look at the table and just double check and make sure that that's what happened. So we see in the table that at x equals 2 there's an error, and you see like it looks like it should just be 0, 1, 2, 3, but the error is there. So that means it's a hole. So our answer is x equals 2 is a hole in the graph. If you zoomed in really close on that graph, you could probably see that the line has a break in it where x equals 2. All right, let's do another one. Okay, so right now we can already see we have some that match up. So our zeros for step 1, so talking about the denominator, so x minus 3 times x minus 3 times x plus 4 equals 0. So what we'll get x minus 3 equals 0, x minus 3 equals 0, I'm not going to write it down twice, x plus 4 equals 0. So x will equal 3 and x will equal negative 4. Well, what are we going to get it out of the top? We're going to get the same numbers. I'll go ahead and write it out though. Alright, so they match. So this means that we don't know whether it's a vertical asymptote or whether it's a hole. So we're going to have to look at the graph again. When you put it in your calculator, make sure that you get the entire denominator in a set of parentheses so that we know all of that's on bottom. Alright, so now we're looking at the graph for that one. If you need to pause the video so you can go graph it real quick, or just go based off of this when you can. Let's look at what happened. So remember, we're looking for where x equals 3 and x equals negative 4. Well, what happens at 3? You see one side of the graph going way up to the sky, one going way down. Okay, that's the asymptote. So right there you can see that x equals 3 is a vertical asymptote. Now, does that same thing happen at negative 4? No, we can't even see. So if you go look at the table, you'll see it's still an error, but it's definitely not an asymptote because the graph goes through that point. So x equals negative 4 is going to be a hole. Okay, the vertical asymptotes are really pretty much obvious to see. The holes are not obvious, but because they're not obvious, it's kind of, you see what it is. Alright, and there we go. So that gives us that answer.